Hi everybody. So today we're talking about quadratic functions, and we want to really look at their key features today. Quadratic functions are the basic quadratic function is y equals x squared. Okay, that's your parent function. These are functions that kind of look like a U shape, whether it's opening up or opening down. It could be an upside down U. Okay. When we're looking at key features, they share some of the same key features as linear functions and as all the other major functions that we study in algebra. The y-intercept is where the graph crosses the y-axis. Okay, so generally we're going to write that as a point of 0 and then whatever that y value is. Okay, so it's where it crosses the y-axis. Your x-intercept is going to be where it crosses the x-axis. Okay, because this is a parabola, if you have if it crosses the x-axis twice, once going in each direction, then you're going to have two x-intercepts. Okay. However, if it crosses only once, then you're only going to have one x-intercept. Okay. So, a parabola that looks like this, where it only crosses at that one point, that you're only going to have one x-intercept. And it's possible that your parabola never crosses the x-axis at all. It never touches it. In that case, you will have no x-intercepts. Okay. Your 0 is the x value of your x-intercept. So again, you could have 2, you could have 1, or you could have none. It just depends on where your parabola falls on your coordinate grid. Your vertex is that point where it changes direction. So you can have a maximum if your vertex is up at the top. Okay. You could have a minimum if your vertex is down at the bottom. And when we talk about a minimum or maximum, we're talking about that y value of the vertex. Okay, but this point where it changes direction, where it goes from, instead of going up, now it's going down, or instead of going down and now it's going up, that's going to be your vertex, that point of change. Your axis of symmetry is a vertical line that goes through your vertex. Now, the axis of symmetry is not automatically drawn with your quadratic function. Your quadratic function is that U shape. It's that parabola shape. But we often draw in the axis of symmetry as a visual for ourselves. And the nice thing about the axis of symmetry is all your points are symmetric around that axis. Okay? So if you have one x-intercept, then the other x-intercept, or if you have two x-intercepts, each x-intercept is going to be the same distance from your axis of symmetry. Okay, so that's a nice thing about the axis of symmetry, is that it does allow you to kind of graph things if you only have one side, or make predictions about things. So, all right, so let's actually look at some graphs. Okay, let's start by looking at our x-intercepts. Now, x-intercepts, as you can tell here, we cross the x-axis twice. Okay, so this is an x-intercept, and this is an x-intercept. Okay, so we cross that x-intercept twice, that x-axis twice. We cross it once at negative 1.5 and 0, and again at 4.5, 0. Okay. Because we have two x-intercepts, we also have two zeros. So again, it's just the x value of our x-intercepts. So we're going to have one at x equals negative 1.5 and one at x equals 4.5. Okay. The next thing we want to look for is our y-intercept, and that's right here at 2. So our y-intercept is going to be at 0, 2. Okay. And the next thing we look for is our vertex. Here's our vertex. This is where it changes direction, because originally it's going up. It gets to our vertex and then it starts going down. Okay. So our vertex, that point where it changes direction, is at 2, 6. Okay. Now, this is where the axis of symmetry comes in. The axis of symmetry actually goes through that vertex. It's part of our vertex. Since it goes through the vertex, okay, this is our axis of symmetry. And since it goes through the vertex, our axis of symmetry uses the x value of our vertex. So it's going to be x equals 2. Okay. There are all of our key features. And I'm going to zoom in on the graph a little bit. Let me move it over so I can zoom in. And you can see where all these things are. Okay. Our x-intercepts, or our zeros, are actually where they cross the x-axis. Our y-intercept is where it actually crosses the y-axis. Our axis of symmetry goes through that vertex, which is the highest point. Okay. So let's look at graph number 2. Now, graph number 2, one more thing about our vertex here. Our vertex here actually has a maximum. This one has a maximum value at 6. Okay, it is the y value of our vertex. Okay. And that is because it's the highest point on our vertex. If we look at the next graph here, our x-intercepts. Okay, well, we only have one x-intercept right here. It's the only place it touches the x-axis. So the x-intercept, our 0, those are going to be, so the x-intercept is at -2, 0. The 0 is at x equals -2. Our y-intercept is going to be here at 0, 4. And then we start looking at our vertex. Okay, now I want you to notice the vertex is already marked because our vertex and our x-intercept, our vertex and our x-intercept are the same point. So our x-intercept is at -2, or our vertex is at -2, 0. So our axis of symmetry is going to go through x equals -2. So I could draw that axis of symmetry in right here, and it goes through that vertex. And in this case, we have a minimum. Okay. Now, this is still our vertex. Here it is a minimum. It's a minimum because it is at the bottom of the parabola instead of at the top. So our minimum value for this one is y equals 0. Okay. So let's look at a couple more. And I'm not going to label everything on the graph. We'll just talk about it here. Okay. So our x-intercept, we have 2 of them. We have one here and one here. So we have one at -3, 0 and one at -1, 0. Okay? Which means our zeros are at x equals -3 and x equals -1. Our y-intercept is here at 0, 3. Our vertex is at -2, -1. Our axis of symmetry goes through x equals -2. And our minimum goes through y equals -1. Okay, so here's our axis of symmetry. I do want to draw that in because that's kind of an important feature. As you can tell, each of our x-intercepts are the same distance on either side of our axis of symmetry. Okay. Now, I'm going to give you a couple of minutes here. Well, I want you to take a minute or two and look at 4 and 5. See if you can find those key features. Okay. I'm going to write down what you need to look for while you look for it. And if you need to, pause this video, find each of these things, and then I will come back on. I'll start talking again to tell you what they are. Okay? Okay, guys. Hopefully you've paused the video. Now you've unpaused it. We're going to take a look and find these things now. Okay. So if we start with number 4, if I can get my sizing correct again. If we start with number 4 over here, our x-intercepts, we have 2 of them. We have one here at -2, 0, and one here at 8, 0. So our zeros are x equals -2 and x equals 8. My y-intercept is up here, halfway between the 4 and the 6. So my y-intercept is at 0, 5. My vertex is up here. I'm looking at my intervals here. Every other line is marked as 2, so that means that this is 3. And 8, which means my axis of symmetry goes through x equals 3. Okay? So you also needed to figure out if this was a minimum or a maximum. This is a maximum at y equals 8. If we look at our last example, number 5, our y-intercept, our x-intercept. Well, here's our x-axis. There is no x-intercept. This is one that never crosses the x-axis. It never even touches it. So for our x-intercept and our 0, we could just say there are none. Now we do have a y-intercept. It crosses the y-axis way up here at 0, 12. We still have a vertex because it does change direction right here at 3, 3, 3. So our axis of symmetry goes through x equals 3 because that's my x value, and this is a minimum where y equals 3 because, again, that's the minimum value. Okay. All right, guys. I want to thank you for watching this video today. Hopefully this has helped you a little bit so that you can remember key features of quadratic functions. I will talk to you later and have a great day.